Hi, my name is Mark Nottingham, and today I'm going to talk a little bit about APIs and standards. And I want to start with some history. HTTP has been used for machine to machine communication for a long time, almost from the beginning. For example, MomSpider was a Perl script that tracked web metadata written by Roy Fielding in 1993. You might recognize that name. If not, remember it. We will hear it again. MomSpider was great, but it and similar programs were still focused on web pages. For most of the 1990s, people doing integration of software across the network didn't think HTTP was a serious solution, so they focused elsewhere. They were looking for magic, a way to abstract away the network, so that a developer could pretend that remote code was local. Use an IDL to generate some client stubs and poof, you have integration. Really, they should have known better. The seminal note on distributed computing tells us why, and it was available back then. In short, pretending that remote code is local provides a comfortable developer experience, but ineffectively papers over issues of latency, concurrency, and partial failure, the hard problems of distributed systems. Unfortunately, some people in 2020 still ignore the advice in a note on distributed computing. Despite that very good advice, lots of effort was spent on solutions like Corba. These were expensive, difficult to get working well, and had lots of interoperability issues, and generally made people who used them hate life. They were overcomplicated solutions to a seemingly simple problem. By the mid to late 90s, teams in Microsoft started working with external developers on what they felt were simpler solutions to these problems by layering object models on top of HTTP. DCOM was one approach. Digging around in these old specs is kind of fun. Even back then, they were worried about versioning, so nothing really changes. There were a lot of politics inside of Microsoft about this. DCOM was not the only proposal that they were considering. So, in 1998, Dave Weiner, one of the external developers they were working with, got impatient and published a fork of one of these proposals as XML-RPC. XML-RPC got traction. This is back in the days when getting an O'Reilly book was a sure sign your project had made it. It was immediately attractive to developers. Instead of paying vendors for Corba object brokers and consultants to figure out how to make it work, you could just use XML and HTTP. Both ubiquitous, widely understood, and free. Eventually, Microsoft sorted itself out, got IBM and some others on board, and published a proposal that XML-RPC was forked from. And so, SOAP was born. They took it to the IETF. I wasn't at the meeting, but according to Roy Fielding, SOAP was, and I quote, dropped on the shower floor as an internet draft and quickly left out of the IETF. So they moved to the W3C for standardization. The W3C is a standards body set up by Tim Berners-Lee and others as the home of many of the web specifications, like HTML and CSS. So SOAP got rebranded as part of web services, so that people could believe it had something to do with the web. This spawned at first one working group to work on SOAP, and then a multitude of others. Web services took many years of industry effort, countless meetings, millions of dollars of product development, and many, many fine dinners. There were lots of smart people involved, including some who were involved in HTTP work previously, like Henrik Fristik Nielsen. Eventually, web services expanded to a monster stack of complicated, interlocking, and sometimes competing specifications. No one could keep it all inside their heads. It was dizzyingly complex. There were, of course, O'Reilly books that tried to help. But sorting this out and defining all the components meant that there was also a fair amount of travel and drinking involved. This is a much younger and more naive me in Amsterdam during some web services meetings. Early on, this all seemed normal, because I didn't know any better. Why shouldn't big, well-known software companies define standards for protocols? After not too long, a number of us became convinced that web services was bloated, not interoperable, over-architected, and only really designed to make enterprise software vendors more money. It didn't serve developers well. This culminated in early 2006, by which time discussion of alternatives was common. Roy Fielding's thesis about architectural styles and network-based software architectures got a lot of that attention because it explained the theoretical underpinnings of HTTP, and by now most people were convinced that HTTP was a suitable basis for APIs, just without all the XML cruft. And of course, the emergence of JSON throughout the 2000s convinced a lot of developers that there was a simpler way than XML's namespaces, schemas, and info sets. For a lot of folks, the final nail in the coffin was when there was an effort to define REST on top of WS star. This is WS transfer, which defined get, put, delete, and create for web services on top of HTTP, of course. DHH called it WS Star, and that seemed to sum up how people felt about SOAP and web services. And that even got its own fake O'Reilly book cover. So that left us with REST, which a lot of people didn't understand, or at least they didn't understand how to apply it to their specific problems. The abstractions and constraints that help HTTP meet the needs of the web don't give enough guidance to developers who need to get two specific pieces of software to interoperate. In the HTTP working group, REST informs a lot of the decisions we make, because we're often running extensions that have to be compatible with the entire web, where there are many implementations of different components and many uncoordinated deployments of them. Most HTTP APIs don't have the same constraints, and they don't need some of the things that REST provides. So, while REST purists gloated over the self-destruction of web services, people who just wanted to use HTTP to get work done didn't see a lot of progress. Sure, they could use HTTP and get value out of it, but they were very much on their own. People tried to write O'Reilly books, but making REST practical proved difficult. This led to what I think of as a period of darkness, where people spent more time on fighting about what RESTful means than focusing on getting their work done. Some people tried to document new conventions and formats, but it was difficult to make progress. Very little got accepted universally, so people had to define everything from first principles. This inertia created a backlash, where people started to talk about using HTTP but not REST, which doesn't make any sense. REST as religion created the need for something else. This is about when I started calling things HTTP APIs rather than REST APIs. Just use the protocol. Don't worry too much about the theory. Let's shift to the present. How are APIs and standards doing after all that history? One bright spot is OpenAPI, which has emerged as a de facto standard for API description. This is no small feat. There were lots of different proposals and opinions about how HTTP API should be described, and it took many years to get here. But API description isn't the whole picture. It doesn't address many of the needs that people have, and arguably many functions shouldn't appear in the description. They need to appear on the wire. You can see this in the emergence of local API standards, collections of best practices and conventions that people use to make the APIs they control cohesive. These are Microsoft design guidelines, but plenty of other folks have them too. I worked on Yahoo's way back in 2006, and I think you'd be surprised at how few differences there are from then to now. Here's another example, Google's API design guide. Notice that they use RFC 2119 language to express requirements, even though it's not an IETF document. And governments are getting in on the action with their own government-wide style guides for APIs. These are Australia's API design standards, and while they're not limited to one company, single country standards aren't much better. Local API standards usually cover a range of topics, from URI design to format conventions and lots of other details. At their heart, they're trying to do a number of things. improve interoperability, promote best practice, and reduce duplicated efforts and costs. These are things that all standards do, but like all standards, they have much more impact when there's a network effect and broad adoption. That leads me to wonder why we continue to make local API standards rather than global ones. Again, the value of standards is in their universality. The more people who adopt them, the more value the community can get from them. People can reuse their knowledge and tools and build value on top of the standards, rather than rehashing them every time they change API providers. Sometimes, we have more than one way to do something because we don't know what the right way to solve a problem is yet. Doing it different ways in parallel helps us to pick a winner. This let 1,000 flowers bloom approach is great for experimentation and evolution, but it sucks for consolidating into a proven approach that we can build value on top of. Or, to put it another way, XKCD 927. Another, and I think more accurate, way to look at this is that local API standards are created by lots of little empires that have good control inside their walls, but can't yet coordinate well outside them. It's a sort of API feudalism, where a lord has control over their manor and can declare local laws at their whim, but a traveler from another land who isn't familiar with them is utterly confused by them. While some things are the same, the details offer in different and surprising ways. And that makes me wonder how we can improve coordination and communication to help develop open API standards beyond description. Looking at the list of things that API standards usually cover, a number of the common topics could benefit from convergence into industry standards. Why don't we have one recommended way that people can do something like pagination, so that tools, best practices, and support for it can be built into the ecosystem? There have already been some standards efforts in this direction. The Problem Details Specification from 2016 defines how to report the finer points of errors in APIs, and it seems to be getting traction in some places. There's also ongoing work that's relevant to APIs, like the Signing HTTP Messages specification currently in the HTTP Working Group. And there are proposals floating around that don't yet have a home, like the rate limit header fields. All of these specifications are internet drafts because the IETF is recognized as the place with the most protocol design expertise for internet protocols and for HTTP. If you want to make sure that your protocol gets a lot of well-informed eyes looking at it, the IETF is good at that. However, there isn't currently a good home for this particular kind of document in the IETF. Many of these specifications have been approved outside the normal working group process, which means that they don't have the benefit of broad input that working group efforts get. We've tried to do some of this in the HTTP working group, but it's not a great fit. There, the focus is on the core protocol and generic extensions to it, and the primary use case is web browsing. While APIs are also important to the HTTP working group, it's difficult to cover so much ground in one place. The community there is mostly low-level HTTP implementers, not API practitioners. That's why there's currently a proposal in the IETF to create an HTTP APIs working group to focus on building blocks for HTTP APIs. This is the draft charter. It hasn't yet been improved, but I think it should be very soon. Think of it as a peer group to the HTTP working group, focused on the API use case. Like the name says, the focus here is on building blocks for HTTP APIs, things like HTTP headers, JSON conventions, and best practices for building services. It's not chartered to work on description formats, or on things that are likely to be used by browsers. Its charter also doesn't define any starting points. It's up to the group to decide what it works on inside that scope. So, it'll be important for this group to have good communication with the Open API initiative. In some places, we'll need to discuss when and how something should show up in the API description on the wire, or in both places. It's also important to recognize that open standards aren't magical. The working group specifications are only as good as who shows up. For the HTTP API working group to succeed, it's important that API toolmakers, practitioners, and other interested parties come and form a community where we can work together to focus on the right specifications and ship things that will help APIs. We need you to show up. With that in mind, I want to wrap up by briefly talking about how you can successfully participate in the IETF. First of all, there is no concept of membership in the IETF. If you join a mailing list, you're in the IETF. This means that everyone participates as an individual. Officially, there isn't any representation of companies or countries. Informally, people know who you work for, but it's not uncommon for two employees of the same company to disagree on a technical point in the IETF. In other words, we all participate as individual engineers. In the IETF, all of the official decisions get made on the working group mailing lists, so it's important to be subscribed so you know what's going on and can weigh in. It's also the place where meetings are announced. Having said that, most modern working groups use GitHub for the bulk of their work, managing issues and the draft documents. This is a lot more efficient than having discussions on mailing lists, and it's where most of the action now happens in groups like HTTP and Quick. So if you're familiar with GitHub workflows, you can easily get started discussing issues and create PRs to propose changes to drafts. The IETF also holds meetings, both in person and virtual, a number of times a year. Right now, they're all virtual. Meetings are a great way to get to know other folks and build community, and they're often used to hash out difficult issues. However, they're not mandatory to attend. Any decision that's made in a meeting will need to be confirmed on the mailing list, so if you don't come, you can still have your say online. Decisions in the IETF are made using rough consensus. This means that there isn't any voting. Instead, the group tries to come to a solution that everyone can buy into, even if it's not what every person would prefer. If there's a solution that's believed to be the best option but a few people are refusing to accept it, they can be declared in the rough. That's where the rough in rough consensus comes from. Just so you know, while there's not voting, sometimes groups use humming as a way to get a sense of how people feel. It shouldn't be used to make a decision, but it can move discussion along, so don't freak out if somebody calls a hum. Finally, the IETF can write specifications about anything it wants to, but if they aren't implemented, it won't matter. Implementation during the specification process has proven to be the best way to assure a sane, reality-based spec and good interoperability. So, I'm telling you about all of this history and about how the IETF works because as enjoyable as good dinners, international travel when we're allowed to, and drinking are, they aren't a good basis for good technology. When I was involved in web services, I didn't know better, although you might argue I should have. Decisions were made by vendors, often behind closed doors, based on product roadmaps and little interoperability to show for it. Since then, I've learned that good protocols are defined by a vibrant community of practitioners in the open, based on sound technical judgment, with running, interoperable code. Sometimes I say that the work I do on HTTP is to atone for any contribution I made to web services. I'm very excited about the HTTP API's working group, but if it isn't well connected to real-world practice and a diverse community, I'll be the loudest person in the room arguing that the group should be closed down. We don't deserve another WS star. So, if you're interested in helping to define building blocks for APIs, and to allow HTTP API teams to focus on their applications, not just local API standards, come help out. You can start by joining the mailing list at this link. When the working group charter is approved, we can start discussing what to work on first. Thanks so much for listening, and hopefully I'll see you there.